It's time to do some proofs. I understand, but this is the last lesson in the unit.
Oh yeah!
Hey, I'm Tammy. I do math for coffee, and we are finishing up my course on congruent triangles in geometry. So first thing we got to do, I've got 2 congruent triangles already. You don't have to prove them, but the proofs we're going to be doing today are going to involve something new that you add on at the end of a proof. And that is called CPCTC. And what that stands for is congruent parts of congruent triangles are congruent. So we've done a lot of proofs already. I've done one in each one of the previous videos. But today we're going to do a few more using this at the end, and I'll show you what the difference is and how you know when to use it. Given that C is the midpoint of BE and AD, prove that AB is congruent to DE. Well, when they're asking you to prove parts, not that just to prove that the 2 triangles are congruent, but to do something with parts, that's when you're going to go one step farther and do CPCTC. Congruent parts of congruent triangles are congruent. Let me show you. Mark your diagram up first. C is the midpoint of BE and AD. So basically they're telling me that C is splitting both of these segments in half. So I've got congruent sides here, and I have congruent sides here. We have vertical angles in the middle. You're allowed to use that. So then you look at the proof and tell yourself, well, which theorem am I going to use? This one is side, angle, side, side, angle, side. So that's what we're going to use. So let's start the proof. C is the midpoint of BE and AD. How do we know that? Well, that was given. You got to get that in the proof. You're not going to be able to talk about these sides being congruent without first establishing in your proof that there is a midpoint. Now we can say that BC is congruent to EC, and the reason we know that's true, that is definition of midpoint. You can say this because this is in your proof the line before, or at least somewhere before. That is our first side. Since we're going to go for side, angle, side, I'm just going to use these letters to kind of organize my thoughts. So the angle now, you have to talk about these 2 angles. So angle BCA is congruent to angle ECD. Those are vertical angles. That doesn't have to be in the given information. You're allowed to use vertical angles because that's a definition whenever you see them in a diagram. And then the last side is going to be the other thing with the midpoint, which is AC and DC. So AC is congruent to DC, and that is also a definition of a midpoint. The next line would be talking about the 2 triangles being congruent. Triangle BCA is congruent to triangle ACD, and the reason is side angle side theorem. That is what we've been doing now for the last few videos, and this would be our last line. But with this one, we're going to use that CPCTC. Now you can just state that AB is congruent to DE. And the reason we know that has to be true is because we've already established that the triangles are congruent. So now we're just talking about other pieces of those same things. So that means congruent parts of congruent triangles are congruent. And that's all you have to write for your reason. So everything we've done in this unit to learn how to write these proofs up to this point still applies. And we just add this new thing on. So this whole video is a review of doing proofs, but we're just going to have this extra line so you know how to handle that. All right, let's mark up our diagram. First of all, they're asking us to do, why is there a question mark there? That's supposed to be an angle mark. Going with it. CPCTC. That's a part. An angle congruent to another angle means we have to show that the triangles are congruent first. Then we're going to pull the CPCTC move. So AC bisects angle. So AC is this segment right here in the middle. And it's bisecting angle BCD and angle BAD. BAD. Well, that's cute. All right, BCD is bisected. So that means these 2 are congruent and these 2 are congruent. Okay, we've got angle, angle, but we also have that line AC, they're sharing that side. So we can use that with reflexive property, and they don't need to tell us that. That's another one of those things we're allowed to use. So we've got angle, side, angle. All right, let's go. Let's get the given information in here. And we know that AC bisects those two angles because, well, they told us. And so I'm going to go for angle, side, angle. So I need an angle situation, which is these two right here we got. So BCA is congruent to DCA, and that is definition of an angle bisector. The side is going to be the one that they're sharing. So that's going to be AC is congruent to CA, and reflexive property, our bud. Now we've got this other pair of angles down here. So it's going to be BAC is congruent to DAC. Same reason, definition of angle bisector, because it's bisecting that big angle down there too. All right, we've got two triangles that are congruent. ABC is congruent to ADC by the angle side angle congruence theorem. And now we can say that angle B is congruent to angle D using the correct angle symbol and not this weird question mark that I'm just not going to go fix. I think that thing has switched a couple times on me working this video, and I'm just leaving it. It wants to be that. That's what it is now, but not in my proof. And the reason that's true is CPCTC. Congruent parts of congruent triangles are congruent. All right, let's mark our diagram up and see what we have here. ADB and CDB are right angles. Oh, right down here. Oop, there's our CPCTC again. Here's our right angles. AB is congruent to CB right there. Oh my goodness, we have right triangles. So that means we have a hypotenuse. We're going to be able to go for hypotenuse leg, and the leg is the shared side in between. Sweet. Hypotenuse leg. Let's go. I've got to put in the given information that I've got some right angles. And then I have to state that the right angles are congruent because all right angles are congruent. That establishes that I'm working with some right triangles here. Once I know there's right angles in there, you are allowed to use the hypotenuse leg theorem because this theorem is not allowed to be used on any other kind of triangle, just right triangles. So we're going to use hypotenuse leg. My hypotenuse is AB is congruent to CB because that was given information. The hypotenusi are congruent. Now the leg is the one that they share. So we've got BD is congruent to DB. And that is because of reflexive property. And that's enough. If they're right triangles, that's all you need. So triangle ABD is congruent to triangle CBD by the hypotenuse leg congruence theorem. And the parts we were supposed to prove are that angle A is congruent to angle C. And since the two triangles are congruent now, we can just do that with CPCTC. I would love to hear from you down in the comments if you are finding these proof videos helpful, either this one or any of the other ones in the unit. Like, share, comment. Thank you guys so much. I will see you in the next one. Bye.